In this video, we're going to see how the CT algorithm in the MCM-View software can help prevent wiring errors. For our first example, we're going to consider a phasing error, which means CTs are installed on incorrect phases. In the Configuration tab of MCM-View, here we have two loads that are configured. The first one, named HVAC, is a three-phase load with 3 CTs, and the second one, interior lighting, is also a three-phase load with 3 CTs. If we go to the Real-Time tab, we have access to real-time measurements. For HVAC, we can see positive kilowatts for each phase, and they're shown as green, indicating correct measurements. For interior lighting, we see negative kilowatts for phase 1 and 3, and they're shown as yellow, indicating possible errors. Going to the load analysis will provide more information on what the wiring or configuration issue could be. We can see that HVAC has a green status LED, indicating that the load measurements look reliable. Interior lighting shows a red status LED, and if we click on plot, we can see vectors that are out of phase. The CT Correct algorithm determines what configuration changes are needed to fix the measurements. Here, assuming this is a lagging load, the CT algorithm suggests assigning CT1 to phase 3 and CT3 to phase 1. Once we click on Accept Lagging Solution, the suggested changes will be applied to the MCM meter. After a few seconds, measurements are now correct. We can see vectors now in phase. And we can now see a green status LED for interior lighting. If we go back to the Real-Time tab, measurements for kilowatts for phase 1 and 3 are now green as positive. If we go back to the Configuration tab, we can see that the configuration of the phase association for CTs has been changed. We can see that CT1 is associated with phase 3 and CT3 with phase 1. This is also shown on the left here, with the green dots showing which phase each CT is assigned to. Now let's move on to example number 2, where we're going to consider a CT orientation error, which means that the CT or current sensor was installed backwards. Same as for our first example, here we configured two loads, HVAC, which is a 3-phase load, and interior lighting, which is also a 3-phase load. If we go to the Real-Time tab, we can see that measurements for HVAC are showing positive kilowatts and they're in green. But for interior lighting, we can see kilowatt measurements in yellow. They're negative, so they indicate a possible wiring or configuration error. Let's go to the Load Analysis tab, and we can see interior lighting has a red status LED. And if we look at the phasor diagram, we can see that vectors are out of phase. The CT Correct algorithm suggests that we reverse CT1, CT2, and CT3. We're going to accept these changes. So we'll click Accept and OK. And after a few seconds, we can see that the vectors are now in phase and the status LED for interior lighting turned green. Now let's go back to the Real-Time tab, and we can see that kilowatt measurements for interior lighting are now in green and positive. And now let's go back to the configuration page, where we can see a red tag next to each CT input, and this means that the CT polarity was reversed for all 3 CTs on this load. We saw a couple of situations in this video and how the CT Correct algorithm helps prevent and even fix wiring errors that would have resulted in incorrect measurements.